G'day team, welcome back to another video. So we're continuing on with our financial modeling and we're going to start looking at different compounding periods. So in the last video we looked at compounding interest paid out every year, but sometimes that compounding interest can be paid in different time periods, okay? So this is in chapter 7b.2 of the Hazy Year 12 General Textbook, all right? So a couple of the different periods we can use when we're looking at compounding interest are listed here. So half yearly, so 2 times per year, monthly, 12 times per year, weekly, 52 times per year, etc. So you got quarterly, fortnightly, daily. So if you do hear these terms or read these terms in a question, this is what they're referring to. So it is a good idea to have this written down, all right, so you can refer to it at any stage. So like we did with the compounding interest formula, we're going to look at a little example and see what's happening, all right? So suppose $4,000 is invested for 1 year at 9% per annum interest, compounded fortnightly, okay? Because it's fortnightly, I look up in my little list here and I see fortnightly, so 26 times per year. So this means that each fortnight, the interest of 9% divided by those 26 payout periods, and that's equal to 0.35%. So every fortnight we earn interest of 0.35%. So the value after one fortnight is $4,000 times by 1.0035. Okay, so that is 100.35%. All right, so we're adding 0.35% to our 100%. In decimal form, this is what it looks like here. After 2 fortnights worth, we've got our 1 fortnight worth times again by that 1.0035. So that comes out to be $4,000 times by 1.0035 squared. And this will continue all the way on until we reach the value of 26 fortnights, which is $4,000 times by 1.0035 to the power of 26, okay? So for interest compounding K times per year, so in the scenario up top, our K times would be 26 times, okay? Our future value is equal to our present value or our initial value multiplied by 1 plus our interest rate over K, so as we did with 9% over 26, that is our I over K, and then K, and that is all to the power K times by N, okay? So an example of this, so $6,000 is placed in an account which pays 6.2% per annum interest compounded monthly. Find the balance after 3 years. So what I like to do, I like to write out our formula, all right? That way we can pick and choose what information we have and what information we can substitute in. So we have our initial value PV. We have our interest rate at 6.2%. We're told that it's compounded monthly, so that means K equals 12. And we need to find the balance after 3 years, so N equals 3. So all we're doing is substituting all that information into our formula, putting that in the calculator, so our future value equals approximately 7,223.07. So then what we do with these questions, we need to state the answer. So therefore, the balance of the account after 3 years is $7,223.07, making sure we round to that nearest cent. The second example I'm going to run through is when we're trying to find something other than our future value. If we're trying to find our initial value, our interest rate, our how many times the interest paid compoundly, and then also the amount of years that we have done this compounding interest for. So I'm going to go through one of those examples. So myself, Mr. Virgo, invested his life savings into an account which pays 8.7% per annum interest compounded quarterly. All right, so there's our key here. After 12 years, the total balance was $1 million how much life savings did I have initially? So again, like I said, writing out our formula and seeing what information we have in the question. So we have our future value, which is our $1 million, equals, we don't know the initial balance, so that's what we're going to be finding. And then we know our interest rate, because it's quarterly, we know it's being paid 4 times, and then after 12 years. Now, all we're doing is solving for PV, so we're going to divide both sides by this whole term here. All right, so PV equals 1 million over 1 plus 0.087 over 4, and that's all to the power of 48. So this means, this is approximately equal to 356,005.72. Therefore, I had $356,005.72 in my life savings. And I can tell you what, that's pretty stonks. So have a crack at the questions in 7B.2, and we will catch you guys next time.